Hi Year 10. We're going to move on with probability today. I've had now it is only a very quick look at your work from yesterday. I'm going to try and get a wee bit of a better look at it before this lesson for you. But generally what I have seen has been really, really good. So you seem to have got that stuff from yesterday reasonably well, and working out shown reasonably well as good as well. So that's really good. I don't think I'm going to have time to mark it all properly. So here are the answers from 3B from yesterday. So hopefully if I do that, yeah, ignore that, that's a different exercise. But if you pause and then properly mark your work there, because I don't think I'll have time to mark it all properly. Okay, now today's work, let me get this sorted actually. Right, I'm back. So we've got a couple of exercises to do today. The first one is the situation where we've got two independent events, and if you remember from yesterday's lesson, independent means that one has absolutely no effect on the other one. So it doesn't matter what happens in event A, event B will not be affected by that, right? Now, if you remember yesterday, whenever we had the word or in our probability questions, that meant we added the probabilities together. The rule here that we're looking at today is that if we are looking at what's the probability of this thing happening and this other thing happening, then you multiply the probabilities together. So in probability, can you add this in for me as well? Oh, sorry, I didn't even say what page we're on. Page 40 in your notes. Add this wee in. So in probability, and means multiply. So if you have or something else happening, then you add the probabilities together. If it is the probability of this thing happening and this other thing happening, then you multiply. So this is the rule that we're going to be using today. Now, this first example uses one of these wee possibility spaces or probability tables. Different people call them different things. But I've had a very quick look at the exercise you're going to be doing. I don't think any of them ask you to do this, but it'll do us no harm to remember. So when a coin is flipped and a dice rolls simultaneously, so two completely separate things, independent, the outcome in one has no impact on the outcome of another one, then we can use the table to list all the possible outcomes. So these are our outcomes for our coin, and these are the possible outcomes for our dice. So one of the possible outcomes is that we get a head and a 1. One of them is that we get tail and 1. And then you just have to fill in the rest like that. So head and 2, tails and 2, etc. So you can fill in the rest of that. Pause me here, fill it in, and then we'll meet back in a second. Okay, have that done? Right. So for these examples, I'm going to answer them twice. We're going to do one using the table and then one using this little rule here. Okay, so let's look at the first one. Calculate from the table what the probability of getting a tail and a prime number is. Terrible worded. So let's go from the table here. Right. Now, the way I like to use these tables is to circle the ones that it's talking about. So what's it asking us for? A tail and a prime number. So let's see how many times that appears. So it's obviously not going to be any of these because they're all heads. Tail and 1. 1 isn't a prime number. So if you forget, a prime number is something that has two factors. It has the factor of 1 and itself. 1 just has one factor, so it's not a prime, it's a wee weird one. 2 is the only even number that is a prime because it only has two factors, 2 and 1. 3 is prime, 4 is not, 5 is, 6 isn't. So out of all our outcomes, we have got 3 which fit this criteria. So the criteria here is that it is a tail and a prime number. So probability, tail and prime. right? It's 3 out of however many possible outcomes we have. So we have 12 outcomes altogether. And that simplifies down to a quarter. Now, that there is definitely the easier option if you've drawn one of these tables, but drawing the table is quite time consuming. So if you don't have the table drawn, then you can use this little rule. So from the rule, goes without saying you're writing this down with me, doesn't it? So probability of tail and prime is going to be the probability of getting a tail, and means we use this little rule and we multiply. So multiplied by the probability of getting a prime. Okay, so the probability of getting a tail whenever you toss a coin is a half. It's 1 out of 2 options. And the probability of getting a prime whenever you roll a dice, well, if we hadn't already done this, we would be thinking through what are all the prime numbers, well, half of them, because we've got 3 out of a total of 6. So let's write it as 3/6. It wouldn't matter if we did a half there or 3/6, because 3 numbers on a dice are prime, 2, 3 and 5 out of 6 possible outcomes. Then if we multiply these together, we get 1 multiplied by 3 gives us 12, 2 multiplied by 6. I just said 1 multiplied by 3 gives us 12, but obviously it doesn't, gives us 3. 2 multiplied by 6 gives us 12. And then that simplifies down to a quarter. So same answer. This one, I think you're maybe sitting there thinking that looks like an awful lot of work, but remember for this one, that relies on us drawing out that table as well. Right, let's look at example 2. So what is the probability of picking a head and a number that is a factor of 6? So again, we'll do our 2 options, 1 from the table and 1 from the rule. Now, let's look back at our table. What are we looking for? A head and a number that is a factor of 6. So we'll do the circling thing again, heads. So it's only going to be from this top row then. Factor of 6 is 1 a factor of 6, yes. 2, yes. 3, yes. 4, no. 5, no. 6, yes. So we've got 4 out of a total possible of 12. So probability head and 6 factor, is that how I'll write that? That's terrible. Was 4 out of a possible 12, so that's a third. Okay, from the rule, probability of head and a factor of 6 is going to be the probability of a head, because it's and, multiplied by the probability of getting a factor of 6. So probability of getting a head whenever you roll a dice is a half. Probability of getting a factor of 6, there's 4 factors of 6, so that's 4 6. Multiply these. We could simplify, remember here. Doesn't matter though, because these numbers are nice and easy enough. So 1 multiplied by 4 gives me 4, 2 multiplied by 6 gives me 12, simplifies down to a third. Okay, so you've got 2 exercises you're going to have to do. The first one, I think basically is just using this little rule, the rule of if it's 2 things happening, this and this happening, then you multiply the 2 probabilities together. And then the second exercise is a little bit of a mixture. Let's have a little look at them and I'll have a wee look and see if there's anything awkward in them for you. Right, so 3C is the first one. There's a wee mixture of questions here as well. So 2 coins are tossed. What's the probability that both show heads? That's really, what's the probability of getting a head and a head? So it's going to be a half multiplied by a half, right? 2 dice, double 6. So what's the probability of getting a 6 and a 6? So multiply those 2 together. In question 3, this one is a bit of a mixture. So Jack has 2 tubes of sweets. Each tube contains 10 red and 30 of other colours. So there's 40 in there altogether in each tube. He takes 1 sweet from each tube. See here in part A, what's the probability that he takes a red sweet from a tube? That's just from one of them. So spoiler alert, it's going to be 10 over 40, which simplifies to a quarter, right? B as well is just talking about one of them. So he takes a sweet that is not red. So it's going to be 30 out of 40, 3/4. But C is where we would be applying our rule. So what's the probability that both of the sweets are not red? So it's going to be multiplying the not red by not red. Let me see. One there I think is okay. 5, a mother has an equal chance of giving birth to a boy or a girl. Holly plans to have 2 children. What's probably the first is a girl? Again, straightforward. Both are boys, so that's a boy and a boy. Neither's a boy, then that's a girl and a girl. Let me see. Yeah, I think you could give that one a go as well. Now, exercise 3D then is a mixture where you have to decide whether you're applying this rule from today, the multiplying rule, or the adding rule for if it's an or situation. Let's have a wee look at some of those questions. So, some are mutually exclusive, so that's going to be the or ones. Some are independent, that's going to be the and ones. Honestly, I find it much easier to think of it as, is this an or situation or an and situation, rather than mutually exclusive and independent, right? So 5 or 6, you're going to be adding. Or 1 or 2, adding. A 2 on both, that's an and, so you'll be multiplying. An even number on both, that's an and, so you'll be multiplying. So do you see what I mean about it's easier to think or and rather than mutually exclusive or independent? Let's look at some of these later ones. So there's an or, so you're going to be adding the 2 things. On foot, that's going to be an or. There's a total spoiler here, because the whole point is you have to decide. But honestly, use the or and rule to do that. Okay, so that is your work for today. Give me any questions on a comment on either the post in the classwork or the stream, either or, okay? And I'll be there to help you. See ya.